Okay, so today we're going to talk about inheritance. First, I want to talk about what is an inheritance. Inheritance, usually we say is a relationship. Okay, is a relationship. So one thing, by the way, you can go to GitHub to pick up the CPP04, which has all the source code that's provided here. But I want to, if you look at the directory, there is one file called, I call it GPS CPP03 or GPS CPP03.h. So this was a file we use in CPP03 regarding how to define the GPS class. So if you look at this class, how we define it, if you look at this class, you should already start running this program, but this class has 3 attributes. If you look at this 3 attributes is latitude, longitude, and then we have something called location label. So if you remember the earlier version of GPS.h within CPP01, we didn't have this location label. We only have the latitude and longitude. So I kind of add an attribute called location label within the newer version of GPS.h. So essentially, I change the original GPS, and then I actually have that. Okay, so this, I'm actually going to argue this is a bad approach to do that. So when I realize that I need an extra attribute to the class I already have, what I did is I modified the class. And I feel that this is a bad approach for several reasons. I will challenge you to think about that, why this is going to introduce some problem if our modified class looks like this. So instead, now we try to teach an alternative way to address this problem. And this is what we call inheritance. So inheritance, as I mentioned earlier, just get rid of this, go back to here. Inheritance is what I call is a relationship among class. So what do I mean by is a relationship? So let me show you a diagram about one of the simplest format of the inheritance. So this is inheritance. We have 2 different classes. One class is GPS-DD, is our original GPS class from CPP01. And then I use inheritance to create another class called labeled GPS. And labeled GPS is what we call a derived class or child class. So you can see that now the terminology, sometimes some of the textbook, when they describe this relationship between the one end of the is a relationship and the other end of the relationship, some of the textbook use base class and derived class. So base class is the original one, and derived class means that you want to extend based on that original base class. Or sometimes we just call it parent class and child class. So parent, because it's inheritance. Inheritance, essentially, you inherit everything from your parents. So that's the kind of terminology you can call it. Okay, base class or parent class or derived class and child class. Okay, in this case, I want to tell you that you see that now I have an attribute. I listed attribute on the right-hand side of the box. So the base class GPS-DD has only 2 attributes. One is latitude and longitude. And the derived class, which is labeled GPS, I only define label, which I use this inheritance relationship or is a relationship. I inherit those 2 attributes. So in some sense, with this diagram, the reality or realization of the label GPS indeed has a three attribute. One is defined on its own, and two other they obtain through the is a relationship. Okay, so why do I call is a relationship? Some of you probably already figured out this is the way usually call it, is that the way I say is a labeled GPS object is a GPS object. Okay, you see that is a relationship means that if I'm a derived class, I'm also the base class. So whatever base class has, I can have a copy. And then I have extra. Okay, so I just want to tell you that this is the basic concept about is a relationship, which in this case, we call a single inheritance. Single inheritance means that the child class has only one parent or one base. Obviously, you could have a multiple inheritance, means that you have a multiple base class, and then you form the derived class, which is more complicated. We will address that later, but I just want to first, I want to ask you two things. Whether you understand this diagram and whether you understand the basic idea of what is a relationship. I mean, sometimes we use the term inheritance, sometimes we use the term is a. Okay, any question about this diagram? Okay, good. So today we're going to show you this concept and a few associated features of single inheritance within C++ language, so you can actually develop your own inheritance. Okay, let me go back to my instructional notes. I do want to say a few things. Is that I already covered this part, and I cover this part essentially. Okay, so with inheritance, I'm going to talk about something with constructor and the casting, which is about moving up and down from the inheritance hierarchy. So what do I mean by inheritance hierarchy? You can see that this diagram is very small. It has only two nodes. But in a more realistic project, that you can see that you have a bunch of is a relationship. So what you form is a tree. If everything is a single inheritance, you're going to get a tree. And sometimes we call that is an inheritance hierarchy. Okay, we'll see a more complicated graph like this later in the class. Okay. All right, so I just want to mention that today what I want to do is I will cover single inheritance, constructor, casting. If I have time, I talk about virtual function and also talk about a more advanced version of operator overloading. All right, and just want to connect, because I know some of you are Java programmers, some of you are Python programmer. So I just want to tell you the comparison about the terminology, about what things that language, what each of the language offer in terms of inheritance. So just to let you know, C++, in fact, has three different kinds of inheritance. So one is called single inheritance, one is called multiple inheritance, one is called virtual inheritance. So you just need to know there are three different kinds. I will talk about virtual and multiple inheritance much later. Okay, but right now just focus on single inheritance. But for Java programmer, that Java only supports single inheritance. In fact, I feel that's a good decision. In fact, compare all the three, I feel Java make the best choice. But to implement some of the concept in multiple inheritance or virtual inheritance, Java using something called interface, which is essentially you can accomplish the purpose, but they don't introduce the complexity of the multiple inheritance. And Python is interesting. Python has single inheritance, and Python also have multiple inheritance. But I just want to tell you, if you're familiar with Python, Python's multiple inheritance is actually equivalent to virtual inheritance in C++. This is really confusing for Python programming. Okay, later we'll see what's the difference between the C++ call it virtual inheritance. In fact, it is actually multiple inheritance in Python. And then C++ introduced a different flavor of multiple inheritance. They call it multiple inheritance. Okay, so you can see already the language comparison already causing some terminology confusion. So I want you to understand, especially if you're from the background of Python programmer, you should be aware of that. Okay, all right. So I'm actually going to first show you the example. How do we do that? So let's take a look at this. By the way, any question before I move forward? Okay, so let's take a look at the label this, by the way, this file is label.gps.h. Essentially, we're talking about this file here. Okay, this is the class we try to derive from the original GPS. Let's see how do we do that in the .h file. So first thing, because I need to inherit from the other file, so very important, I have to include GPS.h, right? It makes sense, right? Because I'm building a new class called label_GPS on top of GPS. So it's better for me to include its definition, the .h file. So here is an issue I mentioned a few times about separate compilation. So some of you asked me why I want to separate GPS.h and GPS.cpp. One of the very important reasons is because of inheritance. Well, you can think about inheritance. I'm inheriting, in this case, GPS.h is my own code. So it's very easy for me to access the file. But what happens if this particular class is from Microsoft Foundation class, which is developed by Microsoft, and Microsoft has all the source code, which is represent their intellectual property in the implementation of the class. If we combine these two together, we don't separate the .h and .cpp. What does that mean? It means that Microsoft has to reveal the whole source code in order for us to be able to inherit it from MFC, Microsoft Foundation class. And therefore, we always separate to have a .h file and .cpp file, and such that I only release the .h file, which is giving me enough about the declaration of the class, but without the .cpp portion, which is the source code. And of course, we use separate compilation, means that Microsoft will compile their CPP file into .o and give us the .o file, so we can actually use this particular class. Okay, so that's important to understand why we keep saying we need to separate the .h file and .cpp file. Okay, here is a first line. How do I represent the is a relationship? Just say class label_GPS, and then you say colon, and then put the parent, the parent class. So in this case, I have class label GPS and GPSDD. Okay, I will tell you I can add some keyword here. I can add a keyword such as public, such as protected, or private over here as well. Okay, right now I'm not going through that. I'm just basically using without any keyword. Without keyword is private. Okay, so basically label GPS is a GPSDB. So I just declare that. That's basically helped me to bring everything to me. All right, so now let's take a look at the content of the declaration. You can see that I have this extra attribute I call a label. Okay, instead of a location label, I just call it label. Okay, so I declare this label in the derived class. So now you can see up to this point, I should have all three attributes because I got longitude, latitude from GPSDD through that declaration. And then now I have a label. I essentially implement what I did in the PowerPoint slide I showed you. And then I have a constructor. I have a label GPS constructor, but I have a label GPS constructor. This constructor,
I need 3 arguments because 2 of them initialize latitude, longitude, and one of the argument I need to use to initialize the label. Okay, so that's the 3 things. Yes.
What is the NV underscore dump to base?
I will talk about that.
Yeah, give me a second. So, okay, that is the inheritance relationship in terms of the attribute. By the way, when I did this, not only I inherit all the attribute, I also inherit all the member function as well. And inherit the member function together with that. So I have all the member function, like a get latitude, get longitude is still the same. The way you use it is still the same. But then I have operational overloading. Okay, just to let you know, I define operational overloading. Why I have to define it? Because if I do operational overloading on a GPS location, I only need to compare the latitude and longitude and see if they are the same. But if I want to compare 2 label GPS, I actually need to compare 3 things. I need to compare their longitude and latitude are the same. I also need to compare whether their label are the same because they are the same. I want to see if they're the same label. Okay. So I define this operator overloading here. But now you're probably familiar with this one. This is dump to JSON. But let's see, what's the difference between this one and the one we're using, what do I call that? CPP03. I add a new keyword called virtual, right? I add a new keyword called virtual. And the thing is that virtual, if I define a member function as a virtual, that member function become a virtual function. I haven't told you what is a virtual function, which we will see today. But if I add a keyword virtual, that means this member function is a virtual function. So in order for me to contrast what's the difference between virtual and non-virtual, I also have the other function called NV. So your question NV is non-virtual. It's the same function, but it's regular. It's a non-virtual function. It's the same. If you take a look at the implementation, they're exactly the same. Okay. So let me just show you what the okay. We'll get to that later. Okay. All right. So that's how you define a class. Once you're done here, you're done. Okay, so you take an existing class and you remember use that column, and then you just define your own constructor and whatever function you want to introduce, you can add. Then this is give you voila, a derived class called label GPS. Okay, any question about this code? Okay, we're looking at declaration. Now we're going to look at the CPP, but I want to tell you what I'm going to introduce one by one. So the first topic I want to talk about is, okay, I already talked about the basic of a single inheritance. The next thing I want to talk about is constructor. Okay, it's a constructor. Okay, think about what is a constructor. Constructor is to initialize an object, right? To initialize an object before you can use it. So what they did is they allocate the memory, and then they basically set the initial value of all the attribute, and then you can start using. Well, in this picture, however, just look at this. Imagine this is not the diagram, this is code. So you're looking at simultaneously GPS DD, the implementation, and the label GPS. What's the process for you to initialize? With this inheritance, some of you might already notice, I actually have 2 parts of constructor, or 2 parts of initialization. Yes. Yes. The child. Yeah, that's great. What's your name? Muhammad, right? Muhammad actually provide very good answer. If you have a 2 constructor, we first need to initialize the parent. By the way, this is assuming you only have 1 parent. If you have like parents, and the whole tree, you have to go all the way to the root. to initialize the root and then initialize one level down. Eventually, the last one you need to initialize is labeled GPS. So therefore, in the program, we must have a way to represent this initialization process for them to complete. So now that's the first thing I want to talk about is what is the initialization. So let's go to label.gps.cpp in the same directory. Okay, let's take a look at this one. This is the one that I'm really interested to have, is that this constructor has 3 attributes: latitude, longitude, and the label. That's the 3 arguments. So see how I invoke the parents constructor. Again, I'm leveraging this column. After the declaration of that, well, usually I sometimes do this programming depending on, this is, to me, is a better way to read it. Like this. Okay, so this is the original constructor, but this constructor basically say, hey, I'm going to call the parents constructor. And how to call that is the parents class name. Oh, no, not class name, is a parents constructor name. And then you put this 2 arguments, ARG latitude, ARG longitude. So essentially, those 3 arguments we pass in to the derived class. The first 2 got passed into the parents constructor. And then after that's done, so by the way, the semantics, if you write it this way, that means before you call this part of the code, which is the constructor for the derived class, you need to first call this portion. So you, just like what Muhammad said, we call the parent class first, and then after that, we just call the child class. We say this label is equal to argument label. So by doing this, we will be able to complete the constructor based on this particular to implement this particular single inheritance relationship. Okay, so you can imagine that sometime if you have a multiple inheritance, you are going to put a comma here and add another constructor. Okay, we'll see that kind of complication. But right now, you should only focus on single inheritance because that's the most important feature of the inheritance mechanism. Okay, any question about how to write a constructor for a single inheritance? Okay, so let me go back to my plan. So I talk about constructor. Okay, now I'm going to talk about casting. Okay, I'm going to talk about casting. Right, let me try to run the program. I want to show you now it's time for me to go to the program called test label GPS. CPP. So this is essentially a test program that you can actually manipulate or experiment or twisting the single inheritance example I just provide. So, I mean, if you look at the first part is pretty standard because I'm using label GPS. So I just basically, you need to include the .h file. And then now I'm creating 3 label. I'm creating 3 label. Okay, the first label, just like what we did before, is Home Woodland, TLC, and IKEA Sacramento. You can see that now I just provide 3 arguments using bracket initialization. And those 3 are longitude, latitude, and the label I need to provide. And then, so essentially I create 3 objects over here, but all 3 objects are indeed the what do we call? The label GPS instead of their base class. Okay, let me try to do something. I'm going to call a function that this function is similar to what we did before. So I call it dump to JSON. Okay, I'm going to call the function dump to JSON. And then I call GPS IKEA Sacramento dot dump to JSON. Okay, I'm calling that function. So what do you think when I call this function is supposed to do? What kind of things it should generate for us? Should it generate two line, which is, let me actually run the program. You can see what I'm doing. Let me make it clean. Okay, let me run this program test. Label. Okay, there's a bunch of things. You can see that some of them, I actually got 3 of them printed out. Label, latitude, longitude, and some of them only got 2 of them. So that's what I want to tell you, that under what cases I will be able to get all 3. Under what cases I only get 2. So that's something I want to went over the whole class. Okay, let's look at the implementation first. If I come over here, oh, not this one, sorry. So let's take a look at the dump to JSON. Let's look at the program I'm doing. Let's first look at, in fact, the codes are exactly the same. Dump to JSON and NV dump to JSON. So what is dump to JSON? First, what I did is that, how do I do dump to JSON? I want to display everything in the object. But remember, now my object has 2 parts. One part is in the parent. One part is myself. And so what I did is, you see that here I define a GPS DD object, and I create a parent copy of this derived class from this derived class, and I'm using the first line. So essentially, let's see if you can parse the first line. The first line is I define a parent object, and that parent object I try to create a GPS DD object from the current object. Okay, so what do you think this line is trying to do? Or do you understand what I'm trying to do over here about what I said to get a parent copy? So first, from your second midterm, I realized I have to declare that this is the address of the current object of whatever the pointer point to. The first one is a pointer. So when I do a star this, that means the object is set. Okay, so this is really star this is a dereference of yourself. So yourself is the object, and I basically create a GPS object over here. Okay, so let me just tell you that let me put my comments here. So after I done this, parent copy is a what? Is a GPS DD object without the label GPS extension. Okay, so essentially this line is trying to do is that I create a parent-only object. It's a copy from the original object, and it doesn't have the derived part, which is the label part of the object. Okay, so if the first time you look at this, don't worry, we'll continue with this. So now you see that what I did is I actually call, since I have the parent, I'm actually calling the parent dump to JSON. I call the parent dump to JSON, so I will be able to get longitude and the latitude. Once I get that, I actually also set the label of this label. So essentially in this code, I will be able to get the parent's part, and I will be able to get the derived part. So in this case, if I actually print it out, that will be, the first one is printing from the screen. You can see that the first part is it will be able to have all three of them. Two of them from, they're calling the parent copy, the other one they call it the write. Yes. So if I only put THIS, this is a pointer or it's an address. When you do a star, that means you try to dereference in the content of the thing. And what that this? This is, okay, if I'm an object, this is like this pointer here. So dereference, it becomes feelings, okay? And that's very common, okay, in C++ programming. Okay. I hope you understand how I kind of show you a trick so you can get the dump to JSON to pull out the parent's information and then integrate it with the child's information, and then you will be able to do this way. Okay. Now I want to show, let's move on to see more complicated cases. Okay, so now I want you to focus on this 4 line of code. I'm going to focus. Now we'll talk about casting. Okay, by the way, casting is one of the fairly challenging concepts to learn in C++. So look at this 4 lines of code. I want you to guess, but I want to first explain to you some of the feature. So the first one is I define a pointer to the GPS DD. I call it GPS pointer, which is a pointer not to label GPS. It's a pointer to the parents class. Okay, so it's a pointer. I declare a pointer, but the pointer is pointing to the parent class object. All right. And then the second line, I did something called casting. So what is by the way, I want to ask, get your help. What is GPS IKEA Sacramento? What kind of class this object belongs to? It's a label or GPS? Label, right? It's a label. Okay. So, and then I put an M sign. What is the M sign? That make that object to be the pointer to the object, right? So essentially, if you read this portion, this is a pointer to a labeled GPS object. So far, we're still in the derived class. So that's the pointer to the labeled GPS object. So now I'm casting. I cast what? I cast with a pointer to the GPS. So essentially what I'm saying is that the second part between that parenthesis starting with M, GPS, whatever, that was a pointer to a label GPS. While this part I highlighted is a pointer to the parent. So one is a pointer to the child, one is a pointer to the parent. So what does that mean? Means that I take a pointer to the child class or the object, and I casting it with the pointer to the parent. So essentially, I change the type of that pointer, and then so I can assign to that pointer called GPS PTR, which is the parent, right? So think about this line. This line is essentially I change the type of the original pointer such that it can be assigned to the GPS PTR. Okay, I know this could be challenging, but I want you to think about 5 seconds about what that particular line is doing. Yeah. What happened to the label, right? What's your guess? What happened to the label? Okay,
the thing is that, see, everything there, you actually hit a very important point. You see, everything here is address, right? This address means it's a reference. It's not a content. So essentially what we're doing is just basically manipulate the address, but the content is still there. Okay, so hold on to that thought because I'm gonna, what's your name? What? Assad, I'm going to ask you another question, okay? Follow the, okay, so everybody get that? So far, this line I just highlight. So now I want to ask you one thing. Now I did this. You see that? I'm actually taking that pointer. I call dump to JSON. I call dump to JSON. And what do you think the X will be? Because we say there are either two attributes, which is longitude, latitude, or we have a label. So I only have two possibility. One possibility is that X, after we use the GPS PTR as a what? As a pointer to the parent class, and I use that to call dump to JSON. What do you think I can get? I can get 2 or 3. 2 means latitude, longitude in my output, or 3 means latitude, longitude, and a 3. Go back to Assad's question. If the memory is a 3, then you should only get 2, right? Because the third one is 1. So you want to guess whether it's 2 or 3. Okay, by the way, that's what we need to verify. If I want to say it's 2 or 3, the simplest way is just print it. I just print the X value, right? You call this, and then I want to see what you got. Okay. So let me show you, let me tell you the result. The result is it will give you all 3. If you remember, this is the first printout, this is the second printout. If you remember when I run the program, the first printout is 3. The second printout is also 3.